Alright, so it's section 5.4, and it's x to the 14 plus 14 to the x. Yes, that's it. Oh, I'm sorry. And it's an integral from a lower limit of 0 to 1. Correct. Sorry about that.
No problem. Okay, very good. So we are trying to, first of all, we're asked to find the definite integral. So we have to find the antiderivative and then evaluate at the top minus what we get from the denominator. The first part is easy, right? So we have to increase the power by 1 and divide by that exact number, correct?
Yes.
That is clear. Now you're talking about this one, correct?
Correct.
Okay. Let's analyze this for a moment separately. When we differentiate e to the x, we get e to the x, and we should get times natural log e. That's the correct answer. But we don't write this because it's 1. If it's any other number but e, a to the x, this has to follow everything. A to the x times natural log a. This I cannot consider 1 because a is not e. Is that clear?
Yes, it is.
When I integrate a to x, I have to divide by this. So it's a to the x over natural log a plus a constant c. If when I differentiate, I have times natural log a, when I integrate, the answer has to be this. Here's why. Remember what we said, that the definite integral can always be, indefinite integral can always be checked. Okay, when I differentiate this, I have to differentiate that. The derivative cancel the integration. So from here, I get a to the x. But let's see what we get here. When I differentiate the constant, I get 0. When I differentiate a to the x, I get a to the x times natural log a. This is a constant. It stays in the denominator. There is nothing I can do about it. But a to the x prime is a to the x times natural log a, and that's why these two go away and I have the same. So when I integrate e to the x, I would have had plus e to the x, done. But here I have to have a to the x, which is 14 to the x, everything divided by natural log 14, from 0 to 1. When I differentiate this, I get 14 to the x times natural log 14, which will simplify, and I get 14x to the x. Is that somewhat better?
Yes, it is.
So now I plug in 1, and I get 1 over 15. I plug in 1, and I get 14 over natural log 14. Now careful, minus when I plug in 0, this goes away. But minus when I plug in 0 here, 14 to 0 is 1. So minus 1 over natural log 14. And I have to combine these two. So final answer 1 over 15, but plus 14 minus 1, they have the same denominator, is 13 over natural log 14. Is that better?
Yes, it is.
Yeah, that's the thing. If the base is e, there is no problem. But if the base is anything but e, then I have this. In order to get a to the x, I have to divide by this.
Thank you very much.
Thank you. Good. Next question.
I have another one if no one else has one.
Please do. I'm ready.
It's from section 5.3. It's evaluate the integral, and it has a lower limit of pi divided by 3 and an upper of pi. And then it's sine theta and then d theta. Yes.
Very good. So first of all, and I should have asked here, is this function continuous on 0 to 1? Yes. No restrictions, no restrictions. So it is continuous on 0 to 1. Is this function continuous on 0 to 1? Of course. Sine is defined everywhere. Good. So now I have to ask myself which function prime is sine x? And that is negative cosine. You know what I mean, sine theta. Which function prime is sine theta? It's negative cosine theta. From pi over 3 to pi. Leave the negative 1 outside, don't bother with it. Plug in pi. Well, cosine pi, if you remember, is negative 1. Minus, when I plug in pi over 3, cosine pi over 3 is 1/2. 1 plus 1/2 is 3/2. They're all positive now.
Thank you very much.
Thank you. Is this okay?
Yes, it is.
Next question. Go back to your homework. Please ask anything so we can get this done before Wednesday if possible. Anything else? Anything else?
I got another one.
Please do.
It's related from section 5.1, and it's an oil leak from a tank at a rate of I'll just give you the chart from the very start of it. So it goes T of H, and then 0, 2, 4, 6, 8, 10.
Let me look at the problem better. Is it in WebAssign?
Yes, it is.
Okay, where's my keyboard? Okay, got it. Sorry, I should have been ready for that. I should have had it open. It's opening up. And you said 5.1, and which problem should I look at?
Number 5.
Almost there, almost there. Okay. 5.1, number 5. Yes, I think we did that last time, but that's okay. Let's do it again. So we have, we're not given the function, we are given the table. So time is in hours, and we have the rate of change. So we have 0, and we have 2, and we have 4, and we have 6, and we have 8, and we have 10. And they're giving us 8.7, 7.6, 6.8, 6.4, 5.6, and 5.1. Okay, so they're asking us to find the lower and the upper estimates of the total amount of oil that leaked out. And so as we know, the lower and upper are given by the leftmost point and the rightmost point. And we always know that the area with the midpoint will be between the area either left or right, depending on whether the function is increasing or decreasing. So left or right, I don't know. And then the other one is the area with left or right, I don't know. So if the function is increasing, there will be one direction. If the function is decreasing, a different direction. So all I have to do is determine the leftmost point. So that's not a good color, sorry. So the area with the leftmost point, that will be, the height is at the endmost point. So delta x, and I have 8.7 plus 7.6 plus 6.8 plus 6.4 plus 5.6. That's 1, and I will see whether it's the lowest or not. The area with the rightmost point will still be the same thing, but we start here at 7.6, 6.8, 6.4, 5.6, and 5.1. Once I calculate these two, I will know which one is the lower, and I will know which one is the upper. So 2 multiplied by 8.7, 7.6, 6.8, 6.4, 5.6. And the other one is 7.6 plus 6.8 plus 6.4 plus 5.6 plus 5.1. And I have to multiply by 2. So in my case, so that's 31.5 multiplied by 2. So in my case, the lowest is 63. Low, 63. Of course, the measurement unit is its volume, right? Liters. And high, I got 70.2 liters. There is nothing else we can do. We cannot determine the midpoint. We don't have the function value at the midpoint to get a better approximation. So is that okay?
Yes, it is. Thank you very much.
Thank you. Anyone else? Anything you'd like to ask? Anything? Let's finish up our homework. Let me help you. You choose whatever you want. Can you find anything else?
I have another one.
Please do.
So it's might be easier for you to look on WebAssign.
Oh, yes.
So it's from section 5.2, number 16. I'm not sure if we went over that. Yeah.
No, it doesn't matter. Uh, 5.2, okay, view, 16. No, we have not. Okay, if m, this is one of the properties of the definite integral. If the function is between two values, where m is the lower bound, the upper bound, if you want, where m is the absolute minimum and m is the absolute maximum of the function on the interval a comma b, then yes, indeed, we know that the integral dx, the integral dx, the integral dx from a to b, from a to b, from a to b. We know that. We calculated this. M b minus a less than or equal to a to b from f of x dx less than or equal to m b minus a. Okay, so they are asking us to estimate the integral from 0 to 4 from 7 the square root of x dx. Use this property to estimate the value of the integral. Perfect. Okay. So first I will start with, remember, in all these situations, I have to start with x. So x is between 0 and 4. Whoop. So x between 0 and 4, but remember, this is the same thing with this. I don't care for that 7. It's a constant. It can wait outside. So I'm really interested in this, and then I'll multiply by 7. So the 0 to 4, so x is a number between 0 and 4. But what I'm interested in is to have in the middle here the square root of x. Because all these are positive numbers, I am allowed to take the square root from all three sides. So this is 0, the square root of x, the square root of 2. So now I can multiply because I want to have the entire function. I will multiply everything by 7. I still have 0. I still have 7, the square root of x, and the square root of 14. And I'm using this property that allows us, knowing that this function has a lower bound than the upper bound, then I can do this. So the area under this must be lower than the area under this, must be lower than the area under this. So I have 0 to 4. So the left-hand side is 0. There is nothing I can do to that. That's just obviously the smallest value. Then the integral from 0 to 7, from 7 the square root of x dx less than or equal to, I know how to determine this. Because they already gave us the formula. It's 14 times 4 minus 0. And that is 56. So the smaller, for my example, is 0. And the larger, my example, is 56. Very good example. Very nice.